Hi, and welcome. My name is Brianna Shro, and I am a doctoral student at the University of Arizona studying special education. Today, I'm here to talk to you about curriculum-based measurement in math, an efficient way to monitor your students. Curriculum-based measurement is also known as CBM for short. This is an overview of what I plan to cover in my presentation. First, I will give you a general introduction. Then I will discuss the origins of curriculum-based measurement, what is CBM, what CBM is not. I will also talk about how to conduct CBM in your classroom for math, how to graph a student's progress, and then lastly, how to calculate a CBM aimline. So, in a school, the responsibility is usually to teach children academic skills. However, they're also required to measure the child's acquisition and the mastery of these skills. In my own opinion, the measurement of a child's abilities is just as important as the teaching of those skills. So while some people may place an emphasis on teaching the academic skills or assessing those academic skills, I feel that they are both equally important. In the past, and even in some schools today, classroom testing used commercially prepared tests. An alternative approach to academic assessment has recently become available, though, and this allows teachers to closely monitor the rate of their students' educational process, and this is known as curriculum-based measurement. Curriculum-based measurement was developed over 20 years ago by Stanley Dino at the University of Minnesota. Curriculum-based measurement was developed through a federal contract to develop a reliable and valid measurement system for evaluating basic skills growth. Curriculum-based measurement is also supported by more than 30 years of school-based research conducted by the U.S. Department of Education. There also exists lots of documentation and research to support curriculum-based measurement. There's journal articles, book chapters, and books in the professional literature. So what is curriculum-based measurement? Curriculum-based measurement is a method of monitoring student progress through direct assessment of academic skills in the areas of reading, math, spelling, and written expression. CBM uses brief, timed samples or probes, and the emphasis is on basic skills and fluency. So how fast can the student complete basic skills? CBM can administer daily if desired, or weekly, just depends on the information you'd like to gather, as well as how often you want to conduct it. Performance is often scored and charted or graphed, and then goals are set for progress for the student. Curriculum-based measurement methods of assessment were designed to not only be simple and easy to give, but also accurate. They are also efficient indicators of student achievement that guide and inform instruction. So you can give the curriculum-based measurement, see how the student's doing, set some goals, and that will also inform our instruction as well, because we can see how is the student doing, what should we be teaching, do we need to reteach anything. One thing to note is that curriculum-based measurement is not mastery measurement. Most forms of classroom assessment are mastery measurement. Mastery measurement describes mastery of a series of short-term instructional objectives. Usually in mastery measurement, the teacher determines an instructional sequence for the school year, and I'll show you an example of that, and then they design criterion reference testing to match each step in that instructional sequence. And then the teacher will work on these in sequence until the student has mastered each one. So let's look at an example of multi-digit addition with regrouping. This is an example of a multi-digit addition mastery test. So the students in this classroom would keep completing this until they've mastered this concept. Instead, curriculum-based measurement is a type of formative assessment. Progress is monitored during the instructional period rather than just at the end of the instructional period, like most summative evaluation. So curriculum-based measurement has a major pro because we monitor throughout the year as opposed to just taking an exam or test at the end of the year and seeing how the student's doing, as opposed to being able to look at how are they doing and adjust. Something to note is that curriculum-based measurement is one type of curriculum-based assessment. Just like my analogy here, a thermometer is useful for some but not all purposes. The same is true of curriculum-based measurement. So curriculum-based measurement may be useful for some purposes in your classroom for assessing students, but not all purposes. So keep that in mind. CBM probes are given under standardized conditions. That way everyone gives the same instructions and hopefully we can get the same results and make sure they stay reliable and consistent. Probes can be timed anywhere from 1 minute to 5 minutes, just depends upon the area we're working with, such as reading, written expression, or math. We score for speed, known as fluency, and accuracy. Like I said, these can be given repeatedly. They could be done daily, they could be done twice a week, and then the results are charted. There are numerous advantages of curriculum-based measurement. Number one, they align with the curriculum. They're quick and easy to administer. We can give them often. They're also sensitive to short-term gains in academic skills, as opposed to having students take a test just at the end of the year and seeing how much they've gained in an entire year, as opposed to looking at weekly or even daily progress. They are a reliable means of estimating the academic growth of students in basic skills, and they can also help guide instructional decision making as a teacher. So we can see how the student's doing, do we need to reteach something, or are we ready to move on? Math curriculum-based measurement, unlike reading, the examiner can choose to administer them individually or to groups of students. Curriculum-based measurement reading has to be done one-on-one. There's two different types of curriculum-based measurement math probes. The first one is single-skill worksheets, which contain a series of similar problems. The second one is multiple-skill worksheets. These contain a mix of problems requiring different math operations. And I wouldn't say you see one over the other in classrooms. You'd probably actually see both. No matter the math probe that you give, whether it's single skill or multiple skill, the student is given 2 minutes to complete it. So directions for giving a math curriculum-based measurement are pretty simple. Here's the directions, word for word exactly. First, you're going to give the student the math sheet and a pencil. Then you're going to say exactly this. There are several math facts, or some people say problems, on this sheet. Some are, and you'll want to say the types of problems you're working with. So let's say we're working with single-digit regrouping. When I say begin, work the first problem on the page and work across the row. You want to make sure you're showing them where to work, because some students will want to go straight down as opposed to going across and then down. And this will also make how you grade it or score it much more difficult. If you cannot answer a problem, mark an X through it and go on to the next one. Do you have any questions? So in this, you want to make sure you give a little wait time to the student, because if you just say, do you have any questions? And then you say, begin right away, they're going to think that you think their questions are not important, and in reality they're very important. In case they don't understand the directions, they're confused, or they just have any questions in general. After 2 minutes, obviously you would say stop. How to score a math curriculum-based measurement. So for math CBM, we give credit to each individual correct digit appearing in the solution to a math fact. So we're not scoring for correct answers technically, we are scoring for correct digits. And correct digits, also known as CD. For example, looking at this addition problem, it has a 2-digit answer. Therefore, the student gives the correct answer to the problem as 19, a 1 and a 9. That student receives a score of 2 correct digits because first, they got the 1, which is in the correct place and is the correct digit, and the 9 is in the correct place in the correct digit. By separately scoring each digit in the answer of a computation problem, the teacher is better able to recognize and to give credit for a student's partial math competencies, as opposed to just marking right or wrong. And then you can't see where the student is having difficulties. Here's another example. 46 minus 18, and they have 27. In this subtraction problem, the student placed an incorrect digit in the ones place. However, the numeral 2 that appears in the tens place is correct. Therefore, this student receives credit for a single correct digit in the subtraction problem. Therefore, when we mark this, it would just be one correct digit, 1 CD. Here's some more examples. So like I said, the correct digit is the right numeral in the right place. So not only does it have to be the right numeral, it also has to be in the correct place value. So we have 4,507 minus 2,146. So the first one on your left example, the student has all the digits correct and in the correct places. In the center one, the 4 is incorrect, but they still get 3 correct digits. And then on the last one, the 2 middle digits are incorrect. So they're only receiving 2 correct digits. So in these examples, only the ones in the black bold font are getting credit. The red fonts are the ones that the student got incorrect. But we don't mark that against them as a negative. We just don't count it towards it either. So here's an example of a single skill math probe, just so you can see what it looks like. It says to add two one-digit numbers, sums 11 to 19. Obviously, we'd have more than the problems you see. It would be a whole page, but I'm just showing you an example of what a single skill math probe would look like. This is a multi-skill math probe, so obviously we're looking at more than one skill. So this looks at adding two one-digit numbers, sums to 10, subtracting two one-digit numbers, combinations to 10, and we add two one-digit numbers, sums 11 to 19, and then add a one-digit number to a two-digit number, no regrouping. So unlike mastery assessment, which once a student masters something, we don't look at it again, curriculum-based measurement, we're looking at when it is a multiple skill math probe, including those areas that they've mastered. So as you can see, 1 and 2 here were already mastered, noted by the parentheses, and 3 and 4 are instructional, meaning that they're working on those right now. So basically a summary of how to score math probes. We assign a point for each individual correct digit in the problem. We do not count reverse digits as errors unless they become a new digit. So if a student writes an error or a digit backwards, it's not an error unless it becomes a new digit. We count digits that appear in the wrong place value as errors. We give credit for placeholder spaces written or if they're not written. So let's say a student doesn't have a 0, but we can see that there's a space for the placeholder, they're still going to get credit. We do not give credit for regrouping, carries or borrows, shown on the top. So I've also posted online a math probe for you to look at and score, and I'll also post the directions on how you would give this. If you are a undergraduate student, we will be doing this in class. If you are a graduate student, I recommend perhaps practicing how to give a curriculum-based measurement math probe, maybe to a friend, a spouse, someone you know. Just do it real fast. It doesn't take a lot of time, maybe 5 minutes, because you need a few minutes to give the directions, 2 minutes to give the actual probe, and a little time to score it. Now we're going to move on to charting and graphing curriculum-based measurement data. The reason why we do this is we want to have a chart that shows our progress monitoring. And charts for most people, they're very visual, so it's easy to see as opposed to looking at just numbers. We also list academic behaviors and time on the vertical axis, and I'll show you an example. We choose the number of weeks that the curriculum-based data will be graphed, so it's really important. Do I want to do this for 10 weeks, 12 weeks, 15 weeks? That will help you set up your graph. And then we label weeks or dates on the horizontal axis. So right here I have academic behaviors and time limit are listed on the vertical axis of the chart. So for this one it was a reading curriculum-based measurement. So we have correctly read words per minute. And then on the horizontal axis, they're numbered by successive weeks, or we can number by the date. So our example on the left, we have weeks of instruction. Example on the right, still weeks of instruction, but we have each date that we gave the probe. So why should we graph? Graphing allows teachers to quantify the rate of student improvement. It's really easy to see students that are doing really well and students that are doing poorly. Increasing scores indicate responsiveness, so scores that are going up, and it's very obvious to see. And flat or decreasing scores indicate unresponsiveness to instruction. So, in this words read correctly per minute graph, do you think this student is being responsive to instruction or unresponsive? Think about it for a minute and justify your answer. If you need to pause the video because you need a little more time, feel free to do so, but I'm going to give you the answer. So this graph, it looks like the student is being responsive because we see the scores increasing. Even though from about week 5 to week 9, it looks kind of steady, we'll notice a really good increase from when we started to week 12. So this student had 20 words read correctly per minute, because we're talking about reading for this graph. And on week 12, they can now read at about 82 words correctly per minute. So they're being extremely responsive over a 12-week period. Let's look at this graph. Do you think the student's being responsive or unresponsive to instruction, and why? If you need to pause the video because you need more time, that's okay, but I'm going to give you the answer. So if we look at this student, they pretty much stay in the same line. We have flat scores and we have decreasing scores. So this student would be unresponsive to instruction. We started at about 21 words read correctly per minute, and we're at about that same rate after 12 weeks, or maybe even a little less. So there's not much increasing here. So either one, will probably need to fix their goal, or two, maybe change our instruction. And this really helps us inform our instruction. So basic steps to graphing. We want to chart baseline data, and we usually use 3 data points, and I'll show you why in just a minute. We also want to find the median point. This stands as the best estimate of a student's actual academic fluency, so how fast they can do it. And we want to set a performance goal, chart an aimline, and evaluate data. You might think I'm going a little too fast, but I'm going to break it down here. So first, once we have our 3 data points selected, so this is our baseline. So even on the first day, you can collect 3 math probes or 3 reading fluency probes of data. So this is reading fluency, obviously, or reading. The median is the middle number. So on here we have 25, 27, and 32 are our numbers. The median, therefore, is 27, which is circled. So when 3 data points are gathered as baseline information, like I said before, the median point stands as the best estimate of the student's actual academic fluency, so how fast they can do it. If we just had one, say 25 or even 32, that's not really an accurate number or measure of how well they're doing, because as we can see, 32 is probably a little higher than they normally would read at. They just did really well that day. Then we want to write our performance goal. So I have one here. We estimated increase in fluency per week times the number of instructional weeks. And then we add the product from step 1 to student baseline data using the median data point. And I have an example for you. So let's say we have an estimated increase of 3 words per minute in reading fluency times 10 weeks. We could also do this with correct digits. So we could say we want the student to get, it depends on the student, but this is just an example, 5 correct digits per week times 10 weeks. We could have the same thing. We could have correct digits versus words. Same thing. Then we add the product of step 1, which is 30 words in here because we're looking at reading, to the baseline of our 26 words, which is what we found with our median point. Therefore, our performance goal equals 56 words per minute by the end of 10 instructional weeks, because we added 30 plus 26, which equals 56. This could also be done with correct digits, as I said. An aim line is basically where we want the student to be by the time they finish. So we place an X on the student's curriculum-based chart for the performance goal. So we've started gathering our data, we have our baseline, we have their goal, and we see where we want them to be. So we put an X where 56 would be if that was our example, as I had in the last slide. Then a line is drawn connecting the student's baseline performance to his or her performance goal. This line we call the aim line. Now there's different ways to evaluate results, but I'm sticking really simple here for you guys. It's called the 3-point decision rule. So if 3 successive points lie above the aim line, we adjust the aim line upward. And I'll show you this as well. If 3 successive points lie below the aim line, we change the instructional intervention. And if 3 successive points lie around the aim line, we don't need to make any changes because the student's doing well. They're where we want them to be. So here's our example. So the first one, if 3 successive data points lie above the aim line is that line in the middle, we adjust the aim line upward because the instruction that we're giving the student, or the curriculum-based measurement, or even our goal, is too low for the student. The student's doing really, really well, so you want to adjust it, not just keep going. 3 successive data points lie below the aim line. We want to change the instructional intervention because it's too hard for the student, and then we adjust our goal. And lastly, 3 successive data points lie around the aim line. We don't need to make a change because that's where they should be. So, if you have any questions about my presentation on curriculum-based measurement in general, please feel free to email me and I'd be happy to answer those questions. Thank you, and I hope you all have a great day.